Hello everyone, today is day 30 of Python Pro from CTC. Today we are going to just have a recap of everything we have studied in the past 10 days. That is the recap of the data structures and algorithms. So let's start. In data structures we saw lists, tuples, sets and dictionaries. As you can see, lists are ordered collection in Python that can contain elements of different data types. They are mutable, meaning you can modify their elements after creation. Lists are versatile and commonly used for storing and manipulating data. Then tuples. Tuples are similar to lists but immutable, meaning their elements cannot be changed after creation. They are often used for grouping related data together, such as coordinate or database records. And these two are linear data structures. Then moving on to sets. Sets are unordered collection of unique elements. They are useful for tasks that require unique values or set operations like union, intersection, and difference, etc. Then dictionaries. Dictionaries are collection of key value pairs where each key is associated with a value. They provide efficient lookup and storage of data and are commonly used for mapping and indexing. And these two are non-linear data structures. Linked list. Linked lists are dynamic data structures consisting of nodes where each node contains a data element and a reference or a pointer to the next node in the sequence. They are flexible and efficient for inserting and deleting elements but may require more memory overhead than arrays. Stacks. Stacks are linear data structures that follow the last in first out principle, the LIFO principle, where the last element added is the first one to be removed. They are commonly used in tasks like function call tracking, expression evaluation, and backtracking algorithms. Queues. Queues are linear data structures that follow first in first out principle, where the first element added is the first one to be removed. They are useful for tasks like job scheduling, process management, and BFS algorithms. Then we have got searching algorithms. In searching algorithms, we saw two algorithms such as linear and binary. Linear algorithm seeks for element in the list sequentially until the target element is found or the end of the list is reached. It has the time complexity of O of n. So to have an efficient searching algorithm, we ended up with binary search. Binary search is a divide and conquer algorithm that works on sorted lists. It repeatedly divides the search interval in half until the target element is found or determined to be absent. It has a time complexity of O of log n. Then at last we got sorting algorithms. In sorting algorithms, we got bubble sort. Bubble sort repeatedly compares adjacent elements and swaps them if they are in the wrong order. It has a time complexity of O of n square. Insertion sort. Insertion sort builds the final sorted list one item at a time by repeatedly shifting elements. It has a time complexity of O of n square like bubble sort, but is efficient for small databases. Then we got selection sort. Selection sort divides the input list into two parts, a sorted sublist and an unsorted sublist. It repeatedly selects the smallest element from the unsorted sublist and swaps it with the first element of the unsorted sublist. It has a time complexity of O of n square. Then we have got merge sort. Merge sort is also a divide and conquer algorithm that divides the list into smaller sublists, sorts them recursively, and then merges back together. It has a time complexity of O of n log n. So that wraps up our recap. Thanks for joining me on this journey of Python Pro. Thank you everyone.